What is clustering? The main idea is to find a group of objects that those objects in the group will be similar or related to each other and different from the other object, which is or we name it unrelated to each other. So as you can see here, I can distinguish visually that this is one cluster, this is the second cluster, and this is the third cluster, and this is in 3-dimension space. So technically, if it was in 2 dimensions, very easy to tell which cluster is in which area. But sometimes if you are in higher dimensionality, you may think that those clusters are not related to each other, but they are really one cluster. Like if those two are in 1 dimension, so most likely they are one cluster and not 2 different clusters. So there is a couple of concepts that we're going to go over in this tutorial. Very variety of algorithms, variety of equations, variety of techniques that just keep in mind the meaning of it. You don't have to go in details and understand each equation or each algorithm. Just I want you to understand how this can be applicable on software. The concept of intra-cluster, which is the distance between the minimum distance between items in the cluster. So and it should be very minimum, whereas the intra-cluster is a distance between 2 different clusters, and as much as this is maximum, as much as those 2 clusters are not related to each other. Why we use a clustering? For many different reasons. Maybe for grouping related documents for browsing. For example, for topics. Let's say that I googled a topic, and I will show you this when we start clustering text and doing some text mining algorithm in the 3rd video of this unit, how news are being clustered together and then generated to the user. Or maybe for grouping genes and have protein that have similar functionality, and this is the future also of the bioinformatics, that in future you will have medicine based on the gene of the person. So it's very hot topic and very important. Or maybe to group stocks with similar price functionality or fluctuation, sorry. Or the most important one, which is summarization, and this is also in the news. Some of us, like recently, we don't have time to read all the news because of the globalization. So you have this feed that comes to you as RSS feed, that you only have the summarization of the huge data, and this is automatic, is not anymore human based. So clustering algorithm can provide you with this kind of techniques. What is not clustering? So don't mix classification with clustering. We notice in classification from the beginning we know what is a class. If you remember the data set of the weather to play tennis or you don't play tennis, so you have 2 different type of classes, either yes to play or attributes or instances of the attributes. Either yes you play or no you don't play. So from the beginning you know the label of your class, you know how many different elements. Where in clustering you don't have this concept. The second one, the segmentation. Also, if you are dividing students, for example, by name or by registration group, this is not clustering because you know what you're doing, and from the beginning it's more related to segmentation. Results of a query. If you are querying results, and if you are doing if you query in Google and you get those results and you try to group them, this is not a clustering. Okay, graph partitioning also is not a clustering. For example, finding relevant or synergy between a graph, this is not clustering. Let me ask you this question: how many clusters do you think we have in this figure? You may say, I have 2 clusters. And you may say I have 6 clusters, and I may say I have 4 clusters. So we don't know how many clusters we have. So deciding the number of clusters is is based on the user. So you are from the beginning, decide the number of clusters, and then you see your results. Are they good enough? If they are good, you decide this is good enough for me, and I am satisfied with those number of clusters. If I don't see the results are good, and there is some parameters, purity and entropy will decide for you how much the class is pure, or the overall results are good enough for deciding if it's good. Another measure than the purity and entropy is sum square error. You heard this term before, the SSE. So it says how much errors I have in my clusterings, and based on it, as much as it is smaller, as much as I would say my clusters are better. Okay, so what is clustering? Clustering is a set of clusters. It's very important to distinguish between two types of clustering: hierarchy and the partitional set of clusters. The partition, you are dividing your data, and you are generating the subset of this data, and the division is called partition. Where the hierarchy, what you are doing, you have a set of nested cluster organized in hierarchy tree, and this is what it's called dendrogram. So this is original point. I may say I have 3 clusters, so this is the partitional clustering, where in the hierarchy what I am doing, let's say that I have those points first. I may have one point, start from the middle. I have those 2 points very close to each other. Those are one cluster. This is, if added to this one, will be a second cluster. P1, if it's added to the P2 and 3 and 4, will be the biggest cluster. And in this case, I have this type of hierarchy, and as you can see, those 2 are one cluster that we saw here. Those 3 are the second clusters, which is here. The P1, which is all of them. And the hierarchy cluster is based on where you cut your data. For example, if I cut in this point, I will have each point in one cluster. If I cut in this area, I will have, this is one cluster, and then I will have the rest as another cluster. If I cut in this area, I will have P1 in one cluster alone, and all those together in one cluster. If I cut in the highest level, I will have the whole data in one cluster. Non-traditional, that will be the dendrogram look like this, like you have cluster, a second cluster, and all the data in a big cluster. There are many different kind of clustering. So some of them they named the fuzzy clustering. There's partial versus complete cluster, heterogeneous versus homogeneous clustering. As I said, you have this as a PDF file. You can go over it and read more in details. I just would like you to start to understand the concept of clustering and how it really works. So what is different type of clusters? Well separated clusters, that very pure. Each cluster has its objects, and there is no relationship between the object in that cluster with another object in the second cluster. Second one is center-based cluster, so the objects are centralized and related to the centroid point. Contiguous clusters, the objects are also has similarity between the objects. Or density-based cluster, property or conceptual type of cluster, or described by object function. Like I will say, okay, all these points in first cluster are linearly related, the second are related in different way. So well separated a cluster is a set of points such that any point in a cluster is closer or more similar to every other point in the cluster than to any point not in the cluster. So here we have 3 well separated clusters. Where the center-based, the cluster is a set of objects such as that an object in a cluster is closer, more similar to the center. So the objects inside this cluster are most similar to the center one. The same here, are more similar to the center one. And the center of the cluster is often called the centroid or the average point of the cluster. And there is another one which is middoid, that is the representative point of the cluster, that you pick a point, like you see this one is not the center, but this point is represent the most of the object inside the cluster. Now, contiguous clusters, you use something, they name it nearest neighbor or transitive. A cluster is a set of points such that a point in a cluster is closer or more similar to one or more other point to the cluster than to any node in the cluster. This is kind of very difficult type of clustering, very difficult to be able to define the blue clusters with the small points and the orange, to separate it from those clusters. Based on the technique you are using, some of them are good enough to find this cluster, some of them are not good to find the cluster. Another type is a density-based cluster. And there is another one which is overlapping circle, which is shared properties. There are some properties in these clusters, and there is another one in this one. And if you can think about it a little bit, those might be not in one dimension. If they are if you are in 3 dimensions, so maybe this is in one space and this is in the second space. But in this case specifically is not the situation. But each cluster of those, there is an overlap, but the relationship between those elements here, conceptually there is a relationship between them, and the element inside this one has some conceptual relationship. So to find a cluster that, this is our goal, to find a clusters that minimize or maximize the object function in this case. And we have something named the global or local object. If you took any optimization class, and this is very popular in the business, you always want to have the global optimization and not the local optimization. And this is NP hard problem. And it's very popular in optimization, especially combinatorial optimization courses. And I may a little bit. So another type is map the clustering problem to a different domain and solve a related problem in that domain. So this is what happens usually. They go from, let's say that the dimensionality is very high. We have a lot of attributes, so they go from very high dimensionality to a lower dimensionality to find the solution. Then they go back to the real dimensionality. And we heard that before when we talked about the sparse data and the problem of finding a relationship between the linear association rules. Also in clustering we have that kind of problem. You might heard before about the minimum spanning tree. If you took any course in programming or in database, definitely you heard that terminology. So how we can find or how we can characterize the data, the input data, and how much that is important for us. It's really important to be able to define the clusters. You have to have some type of proximity, or to decide which distance that you're going to use to be able to separate the data from each other to create the clusters. And we have a problem which is the sparseness, which is we talked about. The attribute also, we may have some noisy data, and maybe the distribution is not known enough for me when I am doing the clustering for this data, and the software should help me to find some kind of correlation between the object to be able to split it. What kind of algorithms that are most popular in clustering? And there are many new, but those are the most popular. The k-means and its variant, hierarchy clustering, density-based clustering. The k-means is very popular clustering algorithm. What it does, k, we don't know what the number of k it means how many clusters you want to have when you split your data. And sometimes you hear about the term 3 means clustering. That means I have 3 clusters. 4 means clustering, I have 4 clusters. So you decide from the beginning how many clusters you want, and the data will iterate by itself and continue until it finds the solution. So you are familiar with algorithms. This is typical like any programming languages. So repeat this until the centroid is not changed until you find the data. And I have some simulation to show you how this is work. Complexity of this one is very high. You pick the distance measure, maybe the Euclidean distance, and the complexity is O, the big O of the multiplication of number point, number of clusters, the iteration, and the attributes. So this is the original data, and I would like to find the clusters. So the optimal clustering will be this one. Maybe a suboptimal cluster that I have maybe 4 clusters in this case, or 3 clusters, actually, because those are in the same color and the solution is not really what I am looking for. If I run the iteration and starting by the centroid, so usually the first point, the one that you see the cross, those are the seeds automatically at the beginning. The algorithm of k-means decide the 3 points that those are the centroid for the clusters. It's randomly picked and they name them the seeds. Then it keep iterate and add more data to this centroid, and then decide to move the centroid to another place where it's more reasonable until the objects are more similar to each other. It keep iterating, and as you can see, the cross is moving around and try to find the data that are similar to each other until in iteration 6 you can see the data are split completely, and k-means managed to split those data into 3 clusters, and it works fine. Still we have those 2 points. We're not sure are they belong to this one or to that one. So that's the importance of the initial points is very, very important. So where those 3 points started from, it's very important. That's why whenever you run a clustering, you will notice that it is repetitive, and when you rerun, the seed that start your clustering with will be different. So it's a good solution even when you run the software Pluto, that you start first with one solution, you don't like the solution, you start again from the beginning and iterate again, so the seeds will be in different place. If you, of course, we're talking about k-means. If you pick the k-means, repeat the same parameters that you have with the same data, you will get different results because the beginning points are different. And how lucky k-means to decide where are those seeds from the beginning, where are those centroid, is based on the random points in the data. And this is how some emulation to show you how it's running. The measurement for evaluating the k-means named the sum of square errors, and is very popular. It's the square distance between the points and the centroid, and summed all over all the clusters inside that one cluster and over the whole clusters. So you have the sum squared inside the cluster should be very small, and also for all over all the clusters should be small. There is a problem, of course, with the selection of initial point, as we mentioned before. Don't pay attention a lot to the equations. Just understand the concept more than the iteration, more than the equations. This is if we run 10 clusters example instead of having 3 clusters. As you can see from the iterations, the centroid point trying to find, and it continue until find a good result. So there is another way of solving the problem, especially if you have a huge amount of data. Let's say you are clustering news on the web, and you don't want to start from the beginning after you did the clustering. This takes days and days until you find the best clusters. Sometimes they do what's named incremental update. That means when a new news added to the web, you don't go and recluster all your previous data. You just incrementally add those data to the previous clusters and try to fit them in the right place. This is the idea of the incremental. There is a pre-processing. You have always to do normalize your data, take off the outliers, and then post-processing. After you get to clustering, you have to evaluate your results based on the sum of squared error. Now I should mention here the outliers sometimes are important to keep, because this is how the fraud detection can be found in data. So usually credit card companies, they run the clustering algorithm on your credit card, and they see what kind of behaviors you are doing over the years. And one day, for example, a suspicious behavior happened, like for example a transaction, they know that all your transactions happen in US, and then a transaction of your credit card happen in Europe. So they will call you and they close your account, and they will tell you this is a suspicious, this is something unusual in the account. Of course, there is nothing manual. Everything is based on the automatic system, machine learning, data mining, web mining in this case. And so they will tell you there is this outlier that this transaction happened outside the United States. So are you agree with this one? So if you are the one who is in Europe for that period of time, you will confirm. If not, the transaction will be deleted, and the process will be followed. Another type of k-means is bisection k-means, which is we split the data into two. Instead of starting with the old data, you split and then you do the iteration again. So this is some simulation for that one. Okay, so we are splitting, then we are deciding with the second iteration where's our centroid, the third iteration, the fourth iteration, and the fifth iteration, until we find the clusters, and the 7, 8, and until we get the 10. This is the best clusters. We have 10 clusters here. This is the best place, that's the best fit for all the clusters to be separated. K-mean has a problem because especially when the cluster has different size, different density, and different shape. So K-means has problem when the data contain also outliers. This is the original point. For example, what K-means will do for us for 3 clusters, we'll decide with the centroid that this is the best solution for us. As you can see, this is wrong. It took the blue points here, or it should be related to the middle cluster, and here the green also the green points here are related to this one, and as you can see, so it's not a good clustering because the size is different. This cluster is bigger than those two, so the k-means always rely on the same size of the cluster, so cannot solve this type of the problem. This is another problem. You can see how k-means solve it. It found the centroid, divided the data. This is one cluster, second cluster, and this is the third cluster, whereas the right solution should be this is one cluster, second cluster, and third cluster. Another type of a problem that with shapes, when we have globular shapes, k-means will not work right. So if we know that we have 2 clusters, if k-mean works, this is how it does it. Like this is one cluster, and this is the second cluster, which is, you can see the interference between the data, and this is wrong and this is wrong. So k-means strive to find circular shaped cluster of equal radius, no matter that the data set what it is. So this is big problem. How you can solve this problem if only you have k-means is to use too many clusters. Of course, you will tell me maybe the best solution to put each point in one cluster and your problem solved. Of course, your problem solved, you'll get high purity and 0 entropy, or your sum squared error is 0. So, but you ended up with nothing. You ended up with each in use. If you want to map it to the web, you ended whereas each news with one cluster, there is no relation to the category that we have on the web. So we look again. This is how k-means does. So it's split well, but really, how many clusters created for us? 1, 2, 3, 4, 5, 7, 8, 9, 10 clusters. And yes, they are separated on each other, but technically we only have 2 clusters. So this is the end of first video. Please watch it and look at the second video to see the solution to such as a problem with different kind of clustering algorithm, not k-means. See you in the following video.